China has managed to bring moon rocks back to Earth, first mission to do so in over 40 years.
For almost 50 years, the moon sat silent, forgotten. A dusty memorial to humanity's brief age of exploration in the 1960s and early 70s. After Armstrong's footprints and the final Soviet sample returns, we turned our telescopes toward Mars, toward Jupiter's moons, toward distant exoplanets circling alien stars. The moon became yesterday's achievement, a barren rock we'd already conquered. Nothing left to discover, nothing left to prove. But something fundamental changed, quietly, without the media spectacle of Apollo or the Cold War drama of Sputnik. A new chapter in lunar exploration began, and this time the script wasn't written in Washington or Moscow, it was written in Beijing. While NASA debated budgets and SpaceX perfected landing rockets, China executed something remarkable, a meticulously planned lunar program that has fundamentally rewritten our understanding of Earth's closest neighbour. Their spacecraft reached places no human technology had ever touched. They returned samples unseen for over 4 decades. And hidden in that lunar dust, they discovered something that could reshape the global energy landscape for centuries. So the question isn't just what China found up there. It's what these discoveries mean for the future of energy, for space exploration, and for the emerging competition over who controls the most valuable real estate in the solar system. Let's start from the beginning, because understanding where China is today requires understanding how deliberately they got here. The China National Space Administration was established in the early 2000s with one clear objective: transform China into a major spacefaring nation. But unlike the frantic competition of the Cold War era, where superpowers raced for symbolic victories regardless of cost, China adopted a fundamentally different approach. Methodical, patient, incremental. Each mission carefully building on lessons from the previous one. No wasted effort. No rushed timelines sacrificing capability for propaganda. Just steady, calculated progress, ensuring each achievement became irreversible advancement toward the ultimate goal. They named it the Chang'e program, after the legendary Chinese moon goddess said to have ascended to the heavens seeking immortality. It's more than poetic naming. It's symbolic of China's ambitions. Not a brief visit, not a flags and footprints moment. Permanent presence. The program launched in 2007 with Chang'e 1, China's first lunar orbiter. The mission was straightforward but essential. Map the entire lunar surface in 3-dimensional detail. Measure composition. Study gravity. Build a comprehensive database of lunar geography and geology. But even in that initial survey, scientists detected something extraordinary. Traces of helium-3, an isotope virtually non-existent on Earth, but potentially abundant across the Moon. At the time, it registered as an interesting scientific footnote, a curiosity worth documenting. Nobody realised this discovery would eventually reframe the entire reason for returning to the Moon. Because helium-3 isn't just rare, it's potentially the most valuable substance humanity has ever discovered. More on that shortly. In 2010, Chang'e 2 followed its predecessor into lunar orbit, this time flying dramatically lower, skimming just 15 kilometres above the surface. Its high-resolution cameras photographed potential landing zones in exquisite detail, preparing for the next critical phase. Each mission wasn't isolated. Each represented a deliberate step in a long-term strategy, from orbital reconnaissance to soft landing, from rover operations to sample return, from near-side exploration to far-side pioneering. Every new capability built systematically on foundations laid by previous achievements. China wasn't just returning to the Moon. They were methodically establishing themselves as leaders in humanity's next chapter of space exploration. Written not through hasty rivalry, but through precision, patience and strategic planning. And that patience was about to deliver spectacular results. 37 years. An entire generation. That's how long Earth had been absent from the lunar surface. Not since the Soviet Union's lunar 24 mission in 1976 had any nation achieved a controlled soft landing on the moon. People grew up never experiencing what it meant for humanity to actively explore another world. The moon became something you read about in history books, not something happening in real time. Then in December 2013, China accomplished what many considered impossible for a relative newcomer to spaceflight. Chang'e 3 descended through the black vacuum and touched down in Mare Imbrium, the Sea of Rains, one of the moon's ancient lava plains. Two historic firsts: China's first landing on another celestial body, and humanity's return to the lunar surface after nearly 4 decades. Down the ramp rolled Yutu, the jade rabbit, a 6-wheeled rover named after a mythical creature from Chinese folklore said to inhabit the moon, eternally preparing the elixir of immortality for the goddess Chang'e. This wasn't mere technology, it was deliberate cultural symbolism woven into cutting-edge engineering, a bridge connecting ancient mythology to modern exploration, between those who dreamed of celestial palaces and those who built machines to actually reach them. But Yutu carried more than symbolic value. Mounted on its frame sat the first ultraviolet telescope ever deployed on the lunar surface. From the airless environment of the moon, with no atmosphere distorting incoming light, this telescope could observe the cosmos in wavelengths impossible to study from Earth. The moon itself became an astronomical platform, a base for deep space observation. With Chang'e 3, China became only the 3rd nation in history capable of operating robotic vehicles on another world. Not symbolic theatre, not propaganda. A genuine demonstration that a new space power had arrived with serious long-term capabilities. But 6 years later, China attempted something even more ambitious, a destination never reached by human or machine: the lunar far side. Consider the challenge. The moon is tidally locked, meaning the same hemisphere perpetually faces Earth. The opposite side, the far side, eternally faces deep space. Throughout all of human history, that hemisphere remained hidden, unknown, literally unreachable by our eyes. And there's a massive technical obstacle. From the far side, direct radio communication with Earth becomes impossible. The entire mass of the moon blocks signals completely. Any spacecraft landing there operates in total communication blackness. Chinese engineers needed a solution, and what they designed sounds like pure science fiction. In 2018, they launched Queqiao, the Magpie Bridge relay satellite. Named after a celestial bridge from Chinese legend that reunites separated lovers, this satellite positioned itself at the Earth-Moon L2 Lagrange point, a gravitationally stable location approximately 65,000 kilometers beyond the moon. From that position, suspended in perfect gravitational equilibrium, Queqiao could simultaneously observe both Earth and the lunar far side, a cosmic relay station receiving signals from the hidden hemisphere and transmitting them home. Brilliant, elegant, and absolutely essential for what followed. In January 2019, as the frozen lunar dawn approached, Chang'e 4 began its historic descent. The world watched, though nobody could observe it happening in real time. All data bounced through Queqiao with inevitable delay. The lander touched down inside von Karman crater, located within the massive South Pole Aitken Basin. This basin represents the largest known impact structure in the entire solar system. A scar 2,500 kilometers across, carved by an asteroid collision so catastrophic, it excavated material from deep beneath the lunar crust. The rocks here date back over 4 billion years, older than Earth's oldest mountains, older than most of the moon's near side. From the lander emerged Yutu-2, an upgraded jade rabbit, and the images it transmitted through Queqiao stunned planetary scientists worldwide. The far side looked nothing like the moon visible from Earth. No dark Maria, those smooth lava plains, no flat terrain, just ancient, heavily cratered highlands, jagged peaks, a landscape frozen in time from the moon's violent formation. U-22's instruments analysed the surface composition and detected something remarkable. Rocks apparently originating from the lunar mantle, the layer deep beneath the crust. Material buried for billions of years, exposed only by that ancient, catastrophic impact. First time in human history such deep lunar material had been directly studied. A window into the moon's internal structure and formation history. Even Jim Bridenstine, NASA's administrator then, bound by US law prohibiting cooperation with China's space program, publicly congratulated the achievement, because regardless of geopolitics, Chang'e 4 represented genuine exploration into the unknown. For the first time, humanity had explored the perpetually hidden hemisphere of our oldest companion. The far side transformed from mystery to accessible frontier. And what lay buried beneath that ancient cratered surface was just the beginning. Beneath the moon's cold, airless surface exists a treasure unlike anything on Earth. A substance so rare and potentially valuable, it could power human civilization for millennia while producing virtually zero pollution or radioactive waste. When Chang'e 5 returned to Earth in December 2020, it carried 1.7 kilograms of lunar material. First fresh lunar samples delivered home in over 40 years. Not since Lunar 24 had anyone brought moon rocks back. And within that grey dust, Chinese scientists discovered something genuinely extraordinary. A previously unknown mineral. One never catalogued in any geological database. They named it Changesite. Why? A transparent crystal with complex, unusual atomic structure. And embedded within that structure were traces of helium-3, the rare isotope first detected by Chang'e 1's orbital surveys back in 2007. Here's why this matters so profoundly. Helium-3 is incredibly scarce on Earth. Our planet's magnetic field deflects the solar wind particles carrying it. But the moon has no magnetic field. For billions of years, solar wind has bombarded the surface, implanting helium, 3 atoms into the regolith. Scientists estimate over 1 million tons of helium, 3 sites trapped in lunar soil. And just 40 grams, barely more than an ounce, could theoretically release energy equivalent to 5,000 tons of coal. 40 grams equaling 5,000 tons. Let that sink in. And unlike uranium or plutonium in traditional nuclear fission, helium-3 fusion produces virtually no radioactive waste, no long-lived isotopes requiring millennia of secure storage, no meltdown scenarios, no weapons proliferation risks, clean, safe, astonishingly energy-dense. If, and this remains a substantial if, we develop practical fusion reactors using helium-3 fuel, the moon becomes the 21st century's equivalent of Middle Eastern oil fields, the ultimate energy resource potentially powering civilization for tens of thousands of years. For Chinese scientists and policymakers, this isn't abstract theory anymore. It's strategic reality. The competition for helium-3 has shifted from theoretical physics to geopolitical calculation. Whoever learns to harvest and utilize lunar helium-3 first doesn't just gain scientific prestige, they potentially control the next great energy revolution. The keys to clean, virtually unlimited power. The moon has transformed from scientific curiosity into the most strategically valuable territory in the solar system. And China is positioning itself at the front of the line. But not all Chinese lunar discoveries came neatly packaged in scientific papers. Some were stranger, more mysterious, harder to explain. In mid-2019, operators controlling U-22 noticed something odd in transmitted images. At the bottom of a small crater, something reflected light differently than surrounding material. Shiny, glass-like, almost metallic under certain angles, completely unlike anything else visible. Mission controllers paused their planned route. Cameras focused on the anomaly, and speculation exploded. metallic debris from unknown spacecraft, impossible liquid on the airless moon, artificial structures. For weeks, Chinese officials released no explanation. The information vacuum filled instantly with theories from plausible to wildly fantastical. Internet forums erupted with alien artifact speculation. When truth finally emerged, it was simultaneously less exciting and more scientifically valuable than wild theories. Impact melt glass. Lunar rock instantly liquefied by tremendous meteorite impact heat, then rapidly cooled into glassy substance. Rich in olivine and pyroxene, common lunar minerals formed through violent geological processes. No aliens, no mystery installations, just the violent history of our solar system, written in melted stone. Yet even without extraterrestrial explanations, the discovery offered insights into impact processes and lunar geological evolution. Then in 2021, Yutu-2 captured something else, igniting internet speculation. On the horizon, perhaps 80 meters away, stood a cube-shaped silhouette, geometric, precise, unnaturally regular against the chaotic landscape. Headlines dubbed it the Mystery Hut, or Lunar Cube. Speculation ran wild: ancient structures, alien monuments, secret installations. As Yutu-2 slowly approached over several lunar days, covering mere meters daily to conserve power, truth gradually revealed itself. Not a structure, a rock, a boulder near a crater edge, viewed from angles and distance, creating optical illusions of geometric regularity. And ironically, when examined closely, the rock vaguely resembled a crouching rabbit. Cosmic joke for the Jade Rabbit rover. These discoveries demonstrate that wonder and rigorous science aren't opposites, they're partners. Reality is strange enough without inventing mysteries. But perhaps the most profound moment involved something tiny, something alive. In January 2019, inside a sealed biosphere aboard Chang'e 4, China carried unlikely passengers to the far side. Cotton seeds, potato seeds, fruit fly eggs, yeast. A miniature ecosystem in protective containment. As Lunar Day began and sunlight flooded the crater, controllers activated biosphere systems. Water released, temperature regulated, and something miraculous occurred. A cotton seed germinated, tiny green shoot emerging, reaching upward in 1/6 Earth gravity. For brief shining moments, life existed on the moon. Not frozen in stasis, not dormant. Actually growing. Living. First biological organism sprouting on another world. The plant survived only days before brutal lunar night descended. Temperatures plummeted below -70 Celsius. The sprout froze and died. But in that fleeting moment, something profound was proven. Biological growth is possible in lunar gravity. With protection and life support, plants can grow beyond Earth. Small, fragile green shoot on grey, lifeless world, but representing monumental step toward permanent human presence beyond home. By 2020, China accomplished what no nation had done in 4 decades. Chang'e 5 successfully returned samples. First sample return since 1976. Collected from relatively young volcanic region, samples contained basaltic rock and volcanic glass. Analysis revealed the moon was volcanically active much more recently than believed. Lava flows just 2 billion years ago, not 3+ billion, as older samples suggested. Then in 2024, Chang'e 6 achieved something even more remarkable. Landed on the far side, collected nearly 2 kilograms, returned them to Earth. First samples ever retrieved from the lunar far side. Material untouched since formation, now available for detailed laboratory analysis. But Chinese ambitions don't end with sample returns. Next missions, Chang'e 7 and Chang'e 8, push into unexplored territory. Target: the lunar South Pole. Deep craters where sunlight never reaches. Permanently shadowed regions where temperatures plunge below -200 Celsius. And in those eternal shadows, scientists believe, lies water ice, frozen remnants from the early solar system, preserved billions of years in the only lunar location cold enough to trap it. Finding that ice changes everything. Water splits into oxygen for breathing, hydrogen for fuel, supports human habitation, foundation for permanent presence. Chang'e 8, expected around 2030, will test revolutionary technology. 3D printing using lunar regolith, turning moon dust into solid structures. If successful, it transforms lunar construction. Instead of hauling materials from Earth at enormous cost, use what's there. Print habitats, print landing pads, print radiation shielding. Ultimate goal, International Lunar Research Station. Permanent South Pole base, operational 2030s. Collaborative project led by China and Russia, explicitly outside US-led Artemis Accords framework. First time since dreaming of other worlds began, we're preparing not just to visit, but stay permanently. And in that pursuit, lines between exploration and competition blur impossibly. Half a century ago, space race was flags and footprints, symbolic victories in ideological competition. Today's race is fundamentally different. Resources, technology, strategic positioning, permanent infrastructure. United States, China, Russia, partners all racing towards same destination. Lunar South Pole, region with water ice, region where permanent bases become feasible. Goal isn't exploration for its own sake, it's permanence. Bases extracting resources, manufacturing fuel, supporting long-term presence, launching deeper missions. But this competition raises profound questions. Legal, ethical. Questions about ownership existing space law doesn't address. Outer Space Treaty of 1967 explicitly states, no nation may claim celestial sovereignty. Moon belongs to all humankind, cannot be owned. But treaty written when lunar bases were pure fiction. Nobody imagined nations actually mining the moon for profit. Now those scenarios aren't fictional, they're engineering problems being actively solved. Legal loopholes are enormous. Treaty prohibits sovereignty claims. Says nothing about resource extraction. Nothing about permanent facilities. Nothing about economic exploitation. United States proposed Artemis Accords, framework establishing lunar cooperation and resource rules. Dozens of nations signed. China and Russia explicitly rejected it, developing their own framework through ILRS partnership. Two competing visions, two coalitions, two approaches to controlling lunar resources. Experts warn whoever masters lunar extraction first gains far more than prestige. Access to helium-3 for fusion, water for fuel, rare elements, strategic positioning for deep space. They potentially control infrastructure defining humanity's solar system expansion for the next century. Moon, once symbol of unity, has become frontier where cooperation and competition exist in uneasy tension. Its grey surface now carries weight of geopolitics, energy security, technological competition, long-term strategic ambitions. And for first time in history, question isn't whether we return. It's who controls it when we stay. China's program has revealed profound truth. Moon isn't dead rock with nothing left to discover. It's treasure trove of mysteries and resources potentially reshaping civilization. Discoveries keep coming. New minerals, water ice, helium-3 deposits, ancient rocks revealing violent formation, evidence making permanent habitation not just possible, but practical. China has positioned itself at the forefront, methodically, patiently, building capability after capability until competing as equals with nations decades ahead in experience. Question now isn't what China found, it's what happens next, when bases become permanent, when extraction begins earnest, when Moon transforms from study object into strategic asset. The answers will define not just space exploration, but future of energy, technology, civilization itself. the moon is whispering again, and this time everyone is listening.